second speaker, Jeroen Coussement, co-founder and CEO of Factry. After some years of experience in the classics, industrial IT world, Jeroen founded Factry in 2016 with a clear goal in mind to unlock industrial data into the digital era. Jeroen will be sharing his experience and show us how to do it ourselves in his talk about getting started with industrial data collection. I give the floor to you.
Thank you. Also immediately 5 minutes of my presentation.
You wish.
So, getting started with industrial data collection. So when we're talking about Industry 4.0, a lot of the attention typically goes to like higher advanced use cases, artificial intelligence, big data, stuff like that. And for good reason, because there's a lot of potential in those technologies. But imagine for a second that you are a process engineer or a continuous improvement engineer in an average production factory, and your boss just attended an Industry 4.0 fair, and he comes back to you and he says, okay, I want to do an artificial intelligence project to improve the quality of our products. Make it happen, all right? And you look around in the factory and you see, okay, I need data. Some data is being collected in some SCADA system somewhere, other data is being recorded on paper, like what this also mentioned, or in an Excel sheet at most. And some machines are just sitting there, not even connected. They're 30 years old, but they're still running, and you need to get data from them. So we've encountered this kind of situation a few times over the past few years, and that's what this talk is about. I'm not going to go into technicalities, it's more like a high-level approach. If you want to get technical, find me at the bar later this evening, and we have to do lunch. So how to get started with industrial data collection. A bit about myself. I'm Jeroen Coussement, founder and CEO at Factry. And at Factry, our mission is to radically simplify access to industrial data, to unlock the full potential of people and processes. How do we do that? We've written a SaaS platform, Factry Historian, which is a platform for industrial data collection. So from industrial systems in a production factory, for example, or from industrial remote assets like wind turbines or water purification systems, and so on. So the system allows you to collect data from those systems, to store them in a database, an open source database, by the way, and then our users can use it for a multitude of use cases. Direct use cases like visualization, historical data analysis, energy monitoring, and so on. But also pass on that data to other applications, and then we're talking about AI or just interfacing it to an ERP system or another software platform for non-direct applications. So yeah, we've been doing that for the past 5 years, both in very small applications, but also for larger enterprises. So we've seen a few projects, and from that experience, we've been distilling 8 critical steps you need to take before embarking on an industrial IoT journey. So I'll take you through them, some of the key takeaways of each point, and then yeah. So step 1 is very simple and maybe very obvious, but often forgotten. Assess your current equipment and industrial IT systems. So it's very good to know before you start talking to other partners and other people to know what you already have, right? So which equipment do you have? Which manufacturers have created those equipment? Are they connected to a network? Do they have a PLC inside them? How many different vendors do I have? Do I have SCADA systems? How many? Do they already collect data? So it's very important to know these things because it will help you a lot further down the road. So questions you should ask yourselves at this point, as I said, from which IT systems, equipment, and machines do I want to obtain data? Which existing hardware and data collection systems are in need of replacement? Because in many cases we sometimes see there are already systems, but they're very old and not used anymore, basically. And then also which legacy hardware assets should be retrofitted. So machines in industry can typically become very old. You don't buy a machine and then replace it after 5 years. You replace it after 15, 20, 25 years. So not everything has an Ethernet port, for example. So sometimes you need to go very MacGyver and add some sensors to your machine to get any data from them. Right? Once you've done that, it's time to map your pain points, challenges, and objectives. And starting with the latter, introducing a data platform in Factry is of course because you want to get some business value out of the data you collect. So while it's impossible to know everything up front, it's good to identify at least some high-level objectives about what you want to achieve further down the road, like in 2 years, 3 years, 5 years. So define some use cases that create actual value for the business. Once you have those, you can combine them with your current state, and then you can see, okay, this is the road to get there, this will be easy, this will be difficult, and then you can do some kind of cost-benefit and identify potential low-hanging fruits to start with. Right? So, some points to take away with this. What questions should collected data answer? Again, it's impossible to identify every question, but at least keep some in your mind. How will it create value? And what functionalities are must-haves and which are nice-to-have? Prioritize. So it's important to know this is absolutely required, or I need this tomorrow or yesterday, and this is something that might be useful in the future. Once you've prioritized, take one of those things and use it as a proof of concept. So it would be foolish to introduce a very advanced data platform in a factory, start collecting all the data, but not doing anything with it. So it's important to immediately also solve a business case in order to create visibility in your organization and to create momentum for further developments later on. So at this point, you define a proof of concept. Make sure you can measure the outcome of is the proof of concept successful. So define some KPIs to really make sure this you can measure if your proof of concept is successful. The second one is rather important. Make sure it's hitting the C-level sweet spots, not necessarily C-level, but make sure that your project creates visibility within the organization, because momentum is really important in these kind of data projects. And then also think about the next steps after your proof of concepts. You want to do something that is in line with the company vision. So if your company is, like the example I gave, focusing on quality and improving quality, it would be foolish to do something that's completely unrelated to that. Like, for example, improving the outputs, which sometimes balances or counterbalances. The more output, the less the quality. So make sure it's in line with the company vision. Next step, put together a small but dedicated IIoT team. Might seem obvious, but we often see, certainly in a proof of concept phase, that there are too many seats at the table. That's why it says small. It's important to have a focus team which allows you to move faster than with big teams, because if you have 15 people around the table, that means you have 15 perspectives and also 15 different priorities. So maybe 4, 5, 6 people, but do make sure those people bring different perspectives to the table, right? So involve someone from IT, from OT, some business people, so that you have different perspectives, but not too many, because it's slowing down along the way. So for your team, identify a colleague that has a proven track record in this kind of projects. It's a lot easier if they have done this kind of thing before. Identify people in the company that have this kind of knack for digital projects. That doesn't mean they necessarily have to work in IT, but they just have some hunger for doing stuff with data. And also think about what these team members, what their roles will be after the proof of concept. So it's potentially a good idea to involve someone like a production team leader or an operator who doesn't immediately have value from the proof of concept you are doing, but has a lot of traction within the shop floor organization and would be able to take your project and give it momentum and traction on the shop floor afterwards. So these kind of people can also be very important in data projects within production. Step 5, not necessarily a step to take, but an advice or a caveat. Resist the lure of problem-specific solutions. And this is something we've much too often seen, is that you look for a solution to a specific problem instead of thinking from a platform. So let's say I want to measure the performance of a specific type of machine, and I start looking for a solution that measures the performance of a specific type of machine. I buy it, it's typically not that expensive, I install it, I'm up and running, there, problem solved. Tomorrow I have another problem, I look for a solution for that problem. And once you've done that 8 or 9 times, you will have 8 or 9 different products, 8 or 9 different vendors, different relations, and you'll have data, but it will be in 9 different systems. So you have 9 data silos where you can't get any data out for later on. So keep that in mind. It's easy to go the direct road, but it's not always the best way, or seldom the best way, actually. So some points of attention. What problem-specific tools do I currently have? Because most of the times those kind of systems will already be in place. Can I replace some of those point solutions with a generic platform? Meaning that if I introduce data collection and some application on top of that, can I make some of those applications redundant? You won't be able to do that with all of them. So the remaining legacy tools, can I connect to them and can I get the data out of them? So that at least they still exist, but I can at least get the data from them and do something with it. This might seem like an easy question, decide on cloud or on-prem storage, but it's not always that easy. Because a lot of companies still have policies that make it difficult to introduce cloud applications. So, of course, in some cases, it's absolutely beneficial to put everything in the cloud, but unfortunately, it's not always possible. So, at this point, you should ask yourself, can I do this according to my company policy? But even if the company is against it, imagine that it's important that you scale your solution to different production sites. Of course, then it's beneficial to have a cloud solution and not repeat the same solution in every factory. So even if then your company policy says, yeah, no, not cloud, that might be a reason to try to convince them to do it anyway. Right? Should you have to stay on-prem anyway? Yeah. Just assess what infrastructure is currently in place and make sure that you have sufficient hardware and resources for this solution. Step 7, involve your machine supplier early on. Let's say, and this mostly goes for discrete industry. In process industry, you typically have well-connected lines that are controlled by a single system. But in a more discrete industry, you typically have workstations with OEM machinery. And experience shows that it's not always easy to get the suppliers of those machines involved for getting data out of them. So they're kind of, it works the way it is, it's our machine and you don't get access to the data. So it needs some time and some massaging of those suppliers to get them on board for your data projects, right? The work you've done in step 1, assessing everything, what you need, and systems that are connected and not connected will be helpful here because it allows you to, you've done your homework before talking to that supplier. You say, no, I don't want your control logic, which is their intellectual property. I just want to know how many pieces you're producing, what's the torque on that motor, and so on. So ask yourself these questions. Does your integrator or your internal team, do you have the technical know-how to talk to that supplier and to convince that supplier to join you on your journey? It's always possible to retrofit sensors, but please make sure to check that it's absolutely not possible to capture data from a machine directly, because retrofitting is almost always more expensive and less maintainable than getting data from the machine directly. And then, if you have the retrofit machines, again, prioritize. Don't do everything at once. Just define some machines to do first for a proof of concept and do the rest later on. And then, last but not least, choose your industrial connectivity or your IoT supplier wisely. I mentioned this specifically. We see a lot of companies that are embarking on a data collection journey. They think, okay, it's data coming from my process. I'll just talk to my PLC programmer or my automation partner, and they'll know what to do. Which is, in some cases, they know what to do, but in many cases, they kind of know what to do because they've done it on the side a couple of times, but they don't really know all the aspects that are involved with setting up an open and generic data collection platform. Equally valid the other way around. Don't talk to a custom software developer, that's an IT company, because they often lack the experience you need in an automation setting. So you really need to look for, internally or externally, for partners that really know both worlds. Actually. Yeah, some questions. Are they talking buzzwords, or are they actually listening to what you need and what are your challenges and providing valid solutions for those challenges? Is it their core business or just a sideline? As I mentioned, sometimes they've done it already, but as more of a hobby project, but that's not what you are looking for. And then number 3, and that's arguably the most important one, transparency, both in technology stack and pricing they're offering. So you really know what you are facing. Those were the 8 steps in general. If I want you to remember 3 things from this talk, it will be these 3 things. Think big, start small. That's not only valid for this kind of application, but for many applications. You should have a bigger vision, but you should take 1 step at a time. It would be foolish to throw all your time and money into building a Disneyland when you have not even built a pony carousel, right? So 1 step at a time. Secondly, involve colleagues and partners, because if you do something alone or with a very, very small team, you will have only 1 or 2 perspectives. So you really need different perspectives on a problem, because otherwise you will be engineering a solution towards a specific user or a specific use case. And that's also something we've seen a few times, like when process engineers start working on a data collection platform, they will be building some sort of second SCADA system with technical naming of everything, and then you come to a business user, and then they say, what's this? I need the guideline, and I need to translate everything. So really involve different perspective from the start on. And then the most important one, keep it open, because you're building something that's not only for today, tomorrow, and next week, but probably for the coming 5 years, and you should really avoid technology that locks you in. Don't let technology lock you in, because, as I said, this is very often iteratively that you work on it. So you can't possibly know all the applications you want to do. Now or in 2 years. So it's really important to keep it open, that you are flexible to maneuver in any way the projects might lead you. All right, thank you very much. Questions?
Yeah, I have a question about your product, the data historian. If I understand it correctly, you basically supply a platform to combine different machines, like in the scale system itself.
Yeah. So what the product actually does, it connects to different systems, either being PLCs or SCADA systems, and just gets all the data in a standardized fashion up to a higher level where you can access it from different IT systems or visualization layer. Nonetheless.
And you also supply this, or you just do the data part?
Yeah, and there's a visualization tool on top of it. So this basic functionality is all included, but that's only that's the direct use case. But it also functions as a pass-through platform towards other applications. Right? So you're not limited to looking at the data through that visualization layer. It's open to other stuff as well.
I'm more of an OT guy, so it's always the same story. We don't have data when you start production, as you said before. You don't have data, they have big dreams to do with the data, and it always ends in a simple dashboard.
Yeah.
How do you solve that? What can be how and when can you make your data, your collected data, valuable? What is it?
Who
nice use case.
Who makes those dashboards?
The OT guy, mostly for themselves.
Okay. I think the most successful use cases we've seen is not building stuff for people, but giving them the tools to build it themselves. So when you start collecting data, as you say, what would be a good use case? That's something I cannot tell what's a good use case for you, but I can help you create or visualize or build a dashboard that's suitable to your use case. And that's also the approach we always take. We train people, show them what's possible, and then with some use cases, we build them together with them, and then afterwards they can do it themselves. We have one customers where I have learned things from the operator in the visualization day because they just gave access to all the operators and they started working together, creating their graphs, and really, it really got them more involved with their job. So it's not about building things for people, it's giving them the tools to build it themselves, and then, yeah, that's an important factor for success, I think.
Thank you.
Does that make sense?
And that's DataOps typing.
Yeah.
What are the typical timelines for these kind of projects?
That depends, and it mostly depends on how well your process is already instrumented. So when we look at process industry, it's typically, an industrial process, it's typically well instrumented. They already have a SCADA system or a central point of access where you can get data from. When we are talking about older factories or more discrete manufacturing, that typically requires a larger pre-project for getting everything connected before you can get data out of it, like the retrofitting and adding communication cards on older machines, that kind of stuff. So there you can easily be talking months. But if everything is already network connected and made available, technically you are up and running in like 2 days. But of course, there's a lot of change management. Identifying which data to log, how frequently, building dashboards, but technically it's wrong.
You mentioned that a good tip is to massage OEMs. What do you see those OEMs doing in terms of data gathering, management?
Well, I say massaging because they don't primarily benefit from helping you get data out of their machine because they sold your machine and that's their business model, right?
Mm-hmm.
What we see OEMs do is most of them are now already working on their own data collection or interfacing platform that they want to supply together with their machine. So that's something, for example, in the brewery world, you see that a lot. You have a line management system for bottling machines where it's fairly standardized, but each vendor has like its own line monitoring system. Data Pockets, for example, a very known one. It's the milk cartons. So they build packaging machines. They have their own line monitoring system. Looms have their own monitoring line monitoring system. So again, the same point solutions. If you are by accident having multiple of these types of machine in your plant, then you have multiple of these systems, and it's very hard to make them work together. So that's a bit.
I have the question, how easy is it to massage them? Because sometimes they are very large, very multinationals, very slow to change something. Do you actually get them to do something?
That strongly depends on the vendor.
Yeah.
So we had very cooperative vendors and very non-cooperative vendors. We once, I think, got faxed in German. It was a loom. We were faxed the serial protocol, the on-wire protocol of a loom. It was written in 1996 or something. It was like a fax document of 30 pages. Here you go. That's how you interface with it. And then, so, not always easy.
Do you also supply intelligence to your customers, or do you just supply the platform?
With intelligence, you mean?
I mean, do you actually advise how to use the data they collect?
Yes. For up to a certain point. So we at Factry, we're not data scientists or business analysts or anything. Mm-hmm. We provide the software. We make it technically possible to collect data and to work on some cases. Of course, we already have experience, so we can show to our customers this is what we typically see for energy monitoring and so on. But will not do any advanced analytics or something for our customers, because, as I said, it's like a pass-through platform. It makes it easy for other companies then to hook onto this data and build other applications. And that's a bit the key. We really want to unlock it into a usable layer for direct and then third-party applications.
That's a more technical question. DataOps technical.
Yeah.
You mentioned the database, the open database. What type of databases are actually the most suited for this type of data? Is it time series or more?
Yeah, this is a typical textbook time series workload. So we mostly use InfluxDB, which is very known in that space, and it's actually proven to work very well for this kind of use case.
And it suits all kinds of data that comes from the machines in the field?
All the kinds is broadly depends. Typically sensor data, right?
Yeah.
Timestamp value, whether it's a temperature or whatever. That's time series data. We do see a lot of customers going making a translation to a higher layer when you want to contextualize that data, because when you're talking about production, you're not always interested just in the temperature at that point in time, but what was the average temperature of this specific batch. And then that batch information is context that needs to be added at a certain point, and then you rise a little bit above the use case for time series databases. So that's something we're actually now heavily developing on a layer that makes that easier to.
So it's a joint project, both of them for
tools that are fit for purpose. And, time series databases are very powerful, but they have their limitations.
To add on the question of the OEMs, how beneficial, and if it even happens, are standards like UMAC? Do you encounter it already? Do you know UMAC? Is it beneficial?
UMAC specifically doesn't ring a bell, but there are a lot of standards, like their brewery standards, PACML for packaging machines.
UMAC is PACML.
Oh, yeah. Okay. Yeah.
So it
PACML
happens and it brings a value, I assume?
It happens, but again, more in like our product doesn't specifically support PACML as a standard. Like this is PACML, you're up and running in no time. But it does help in identifying or at least defining how to get data from that machine. Because when it's in a PACML standard, you know that it has a certain hierarchical structure, and the data that you are looking for, like life cycle state or packs per minute and that kind of stuff, you know where to look for that data. So it does help in a certain sense.
And did you encounter it already at customers, or is it just a dream?
No. Yeah, we've encountered it at a lot of customers. Like the brewery standards, we have a brewery customer, and in 12 breweries, everything is standardized on that same structure in terms of how data is being on the API on which the data is being exposed from the machines, right? So it's actually being used, but more in like larger companies that have, in case of PACML, a lot of packaging machines across the factory. Yeah.
I actually have the same question, but with OPC UA, which is sometimes said to be the hype for industrial IoT.
Yeah.
Do you encounter it a lot, or
95% of our data collection is over OPC.
Okay.
Other protocols are possible as well. Like MQTT is now also becoming very, very successful in that space, and that's more of an IoT protocol. While OPC UA is really an industrial protocol, right? So you see, like the top subsystems mostly coming from IoT, and then the older protocols from automation. But reality is that when you collect data from a factory, you're very close to the automation world. So most of the vendors will have some kind of OPC UA, and if you're unlucky, OPC DA communication. But yeah, that's kind of still the standard.
Okay. Do you see going further with those open standards, the developments they're making to get more broad and then more used? Or like you say, the pub subsystem is also something that OPC UA is looking to implement, and TSN and synchronous network.
I think like those developments specifically will be very useful in device-to-device communication mostly, but of course I think the only successful protocol in 5 years will be an open protocol, or at least those will be the ones that survive, because at this point with what's available at this time, I don't think there's any vendor still large enough to impose, this is now my proprietary protocol, and if you want to interface with me, this is what you have to use. That I think that time is maybe not past us yet, but will be very soon. Okay.